Milky Way stretching across the darkness like a river of light. You know there are billions of stars up there, each one a sun in its own right. The scale feels overwhelming, doesn't it? Your mind struggles to grasp just how vast our home galaxy truly is. Now, let me tell you about something that makes our Milky Way look like a grain of sand on an endless beach. Over 1 billion light-years away from Earth, floating in the cosmic ocean, there exists a galaxy so monumentally large that it defies every instinct your brain has evolved to understand size. Its name is IC1101, and it is the largest known galaxy ever discovered by humanity. Not just large, not just huge, but incomprehensibly, mind-shatteringly massive. Let me put this into perspective. Our Milky Way galaxy, which contains somewhere between 200 and 400 billion stars, stretches about 100,000 light-years from edge to edge. That means if you could somehow travel at the speed of light itself, it would take you 100,000 years just to cross from one side to the other. Think about that for a moment. Light, the fastest thing in the universe, would need 100 millennia to make that journey. IC1101 is between 4 and 6 million light-years wide. Stop and let that sink in. While light takes 100,000 years to cross our galaxy, it would take millions of years to traverse IC1101. If you placed IC1101 over our position in space, it would not only completely swallow the Milky Way, but it would also engulf Andromeda, our nearest large galactic neighbour, and still have room to spare. But the truly staggering part isn't just the width, it's what fills that space. IC1101 contains approximately 100 trillion stars. 100 trillion. That's 250 times more stars than exist in our entire galaxy. Every single point of light you see in the night sky, every star humanity has ever observed, every sun that's ever been named, all of it combined, represents just a tiny fraction of what exists within IC 1101. Think about the sun, our life-giving star. Now imagine 100 trillion copies of it, spread across a space so vast that even light itself seems to crawl across it in slow motion. The human brain simply did not evolve to comprehend scales like this. We evolved to understand the size of trees, rivers, and mountains. We can stretch our minds to grasp the size of Earth, maybe even the solar system. But IC1101 exists in a realm of scale that breaks every mental model we possess. This galaxy redefines what huge even means in astronomy. It forces us to confront a humbling truth about our place in the cosmos. We are not just small, we are infinitesimally, almost impossibly tiny when compared to structures like IC1101. And here's what should keep you awake at night, wondering, questioning everything you thought you knew about the universe. How did something this massive even form? What forces could possibly create a structure containing 100 trillion stars? And perhaps most intriguingly, if IC1101 is the largest galaxy we've found so far, what else is out there waiting to be discovered that might make even this cosmic titan look small? Those questions we just asked aren't just philosophical musings. They're the keys to understanding something profound about how the universe actually works. But before we can tackle how IC1101 became so impossibly large, we need to truly grasp just how much bigger it is than everything we know. Because numbers alone don't tell the full story. Let me bring this closer to home. Our Milky Way galaxy is enormous by any human standard. It contains between 200 and 400 billion stars, each one separated by vast gulfs of empty space. To put that in perspective, our nearest stellar neighbour, Proxima Centauri, sits 4.2 light-years away from us. That's the closest star to our Sun, and it would still take over 4 years travelling at light speed to reach it. Now here's something that should make you pause. Our Sun, moving at an incredible speed of about 828,000 kilometers per hour, takes approximately 250 million years to complete just one orbit around the centre of the Milky Way. Think about that journey for a moment. The last time our Sun was in this exact position in the galaxy, dinosaurs hadn't even appeared on Earth yet. That's how long one galactic year lasts for us. IC1101 contains 100 trillion stars. That's 500 times more stars than exist in our galaxy if we take a conservative estimate, or 250 times more if we use the upper range. Imagine trying to comprehend a structure where the scale we just described, that 250 million year journey, becomes almost trivial by comparison. But here's where it gets really interesting, and where our intuitions about space completely fail us. You might think that with 100 trillion stars packed into IC 1101, it would be an incredibly dense, crowded place where stars constantly collide and explode. But the reality is far stranger. Space between stars, even in a galaxy that massive, is still mostly empty vacuum. The distances are so vast that when two galaxies actually pass through each other, something that happens regularly in the universe, the stars almost never collide. They simply slip past one another like ghosts passing through walls. This is the paradox of cosmic scale. IC 1101 contains 100 trillion stars, but most of its volume is still just empty space. The stars are so far apart that light itself, travelling at nearly 300,000 kilometers per second, would take years, sometimes decades, to hop from one star to its neighbour. Our galaxy feels absolutely enormous when we try to imagine its scale. We think about those 400 billion stars, that 250 million year orbit, and we feel appropriately humbled. We understand, intellectually at least, that we're part of something vast and ancient. But then IC 1101 appears in our telescopes, and suddenly everything shifts. Our galaxy, with all its grandeur and scale, becomes a small suburban neighbourhood compared to a sprawling metropolis. Even light, which crosses our entire galaxy in 100,000 years, would struggle across IC 1101 for millions of years, moving through region after region of stars, never seeming to reach the edge. IC 1101 humbles everything we know about size, scale, and cosmic structure. It forces us to recalibrate our understanding of what a galaxy even is, and it raises an even more pressing question that we haven't yet addressed. If IC 1101 is this massive, if it contains this many stars spread across this much space, what exactly is it? What kind of galaxy could possibly grow to such proportions? Because as we're about to discover, IC 1101 isn't just big, it's fundamentally different from the Milky Way in almost every way that matters. That fundamental difference I just mentioned, it's written into the very structure of IC 1101 itself. And understanding what kind of galaxy this is will unlock the mystery of how it grew so impossibly large. Look up at the Milky Way on a clear night, and what you're seeing is a spiral galaxy. Beautiful, elegant arms of stars sweeping outward from a bright central core, like a cosmic pinwheel frozen in slow motion. Those spiral arms glow blue and white because they're filled with young hot stars being born from clouds of gas and dust. Our galaxy is alive, dynamic, constantly creating new stars to replace the old ones that die. IC 1101 is nothing like that. IC 1101 is what astronomers call a giant elliptical galaxy. The word elliptical might sound technical, but what it really means is simple and slightly unsettling. This galaxy has no structure, no spiral arms gracefully sweeping through space, no organized disk of stars rotating in elegant patterns. Instead, IC 1101 is a smooth, featureless blob of stars, shaped roughly like a football or an egg, with stars moving in random chaotic orbits. It sits at the center of something called the Abell 2029 galaxy cluster, over 1 billion light-years away from Earth. A galaxy cluster is exactly what it sounds like, a massive gravitational congregation of hundreds or even thousands of galaxies, all bound together by their mutual gravity. And IC 1101 doesn't just happen to be in this cluster. It sits right at the gravitational center, the dominant giant around which everything else orbits. But here's what makes IC 1101 truly strange, truly different from our home galaxy. When you look at the light coming from its stars, you notice something immediately. The galaxy glows a dull, reddish color. Not the vibrant blues and whites of young stars, but the tired red and orange hues of ancient stellar populations. These are old stars. Very old stars. Some of them have been burning for over 10 billion years, nearly as old as the universe itself. And here's the critical detail. There are almost no new stars being born in IC 1101. The galaxy has essentially stopped making stars entirely. Think about what that means for a moment. Our Milky Way creates roughly 7 new stars every single year. Somewhere in our galaxy right now, at this very moment, clouds of gas are collapsing under their own gravity, heating up and igniting into new suns. The cycle of stellar birth and death continues endlessly, keeping our galaxy young and vibrant. IC 1101 has given up on that cycle. It's a galaxy that has run out of fuel, run out of purpose, run out of the raw materials needed to create new generations of stars. It simply exists, a massive collection of ancient suns slowly burning down to nothing. This is what makes IC 1101 so different, so alien compared to the spirals we're familiar with. Spiral galaxies are alive. Elliptical galaxies, especially giant ones like IC 1101, are cosmic graveyards. They're the end state, the final form that galaxies take when their active lives are over. But that raises the most important question yet. How does a galaxy become this? How does something transform from a vibrant star-forming spiral into a massive, featureless elliptical giant? What process could possibly create a structure containing 100 trillion dead and dying stars? The answer is violence. Cosmic violence on a scale that's hard to imagine. Because IC 1101 didn't start out this large. It wasn't born as a giant. No. This monster was built, piece by piece, through one of the most destructive processes in the entire universe. And understanding that process will reveal not just how IC 1101 formed, but why it looks the way it does, why it stopped making stars, and why it's destined to remain a slowly fading titan for billions of years to come. That process I just mentioned? It has a name that perfectly captures its brutal nature. Astronomers call it Galactic cannibalism, and IC 1101 is the universe's most successful cannibal. Imagine for a moment that galaxies aren't the serene, peaceful islands of stars we see in photographs. Instead, picture them as predators, constantly hunting for prey in the darkness of space. The bigger the galaxy, the stronger its gravitational pull, and the stronger the pull, the more it can drag smaller galaxies toward itself, consuming them one by one. This is exactly how IC 1101 grew to its current size. It ate its neighbours, over and over and over again. Scientists estimate that IC 1101 has undergone at least 70 major galaxy mergers throughout its lifetime. 70 separate occasions where another large galaxy, perhaps comparable in size to our Milky Way, came too close and got pulled into IC 1101's gravitational grip. 70 times where billions upon billions of stars were stripped from their home and absorbed into this growing monster. But that's just counting the major mergers, the large meals, if you will. Countless smaller galaxies, dwarf galaxies containing only a few billion stars, have also been consumed along the way. These minor additions might seem insignificant compared to the major mergers, but they add up. Each one contributes mass. Each one adds more stars to the collection. Here's how the process actually works, and it's both fascinating and terrifying. When a smaller galaxy ventures too close to IC 1101, the giant's gravity begins pulling on it. Not all at once, but gradually, like a slow-motion whirlpool drawing water down a drain. The outer stars of the smaller galaxy feel the pull first. They get stripped away from their home, flung outward or pulled inward, their orbits completely disrupted by the overwhelming gravitational forces. As the smaller galaxy falls deeper into IC 1101's gravitational well, more and more of its stars get torn away. The galaxy stretches, deforms, and begins to disintegrate. Any gas clouds it contained, the raw material for making new stars, either gets consumed by IC 1101 or heated to such extreme temperatures that it becomes useless for star formation. Eventually, what's left of the smaller galaxy plunges into the core of IC 1101 and disappears completely. Its stars scatter throughout the larger structure, adding to the chaotic swarm of orbits that define elliptical galaxies. Its identity is erased. It becomes part of the monster. Now, here's what's particularly interesting about this process. Remember how I mentioned that IC1101 has no spiral arms, no organized structure? This is why. Every time a galaxy merger happens, it disrupts whatever organization existed before. Spiral galaxies have their elegant shapes because their stars orbit in roughly the same plane, like a spinning disk. But when you throw another galaxy into that disk, everything gets scrambled. The stars from both galaxies end up moving in random directions, their orbits no longer aligned. Do this dozens of times over billions of years, and what you get is exactly what we see in IC1101, a smooth, featureless blob where stars move in every possible direction with no coherent pattern. Each merger also does something else. It heats up any remaining gas in the galaxies involved. Gas needs to be cool, relatively speaking, to collapse under its own gravity and form new stars. But the violent gravitational interactions during mergers pump energy into that gas, heating it to millions of degrees. At those temperatures, the gas is far too energetic to collapse and form stars. It either gets ejected from the galaxy entirely, or just sits there, hot and useless. This is why IC1101 stopped making stars. This is why it's filled with old, red, dying suns instead of young blue ones. The galaxy consumed so many others, experienced so many violent mergers, that it destroyed its own ability to create new generations of stars. IC1101 is the end result of cosmic violence playing out over billions of years. It's what happens when gravity, given enough time and enough victims, builds something truly monstrous. But there's something even more terrifying lurking at the heart of this galactic giant, something that grew alongside IC1101 itself, feeding on the same victims, growing more massive with each merger. And this thing at the centre might be even more extreme than the galaxy surrounding it. That thing at the centre of IC1101, it's a supermassive black hole. But calling it supermassive almost feels like an understatement. This isn't just any black hole. This is one of the largest black holes ever discovered in the entire observable universe. The mass of this monster? Somewhere between 40 billion and 100 billion times the mass of our Sun. Stop and think about that number for a moment. Our Sun, which contains 99.8% of all the mass in our entire solar system, is already incomprehensibly massive to us. It would take over 1 million Earths to equal the Sun's volume. And yet this black hole at the heart of IC1101 has the mass of up to 100 billion suns, compressed into a region of space defined by something called the event horizon. The event horizon is the point of no return around a black hole. Once anything crosses that boundary, not even light can escape. It's the ultimate prison, the ultimate void. For our Sun, if it somehow became a black hole, the event horizon would have a radius of only about 3 kilometers. Tiny, almost insignificant. The event horizon of IC1101's black hole is larger than our entire solar system. Let that sink in. The boundary beyond which nothing can escape, the edge of this cosmic monster, extends farther out than the orbit of Pluto. If you could somehow place this black hole where our Sun sits, its event horizon would swallow Mercury, Venus, Earth, Mars, Jupiter, Saturn, and everything else in our solar neighborhood. All of it would vanish beyond that boundary, crushed down toward the singularity at the center. But how does a black hole grow this large? The answer connects directly to everything we just discussed about galactic cannibalism. Every galaxy, including our Milky Way, has a supermassive black hole at its center. When IC1101 consumed those 70-plus major galaxies over billions of years, it wasn't just absorbing their stars. It was also absorbing their central black holes. Each merger brought two supermassive black holes together. They would spiral inward toward each other, releasing tremendous amounts of energy in the form of gravitational waves, before finally colliding and combining into an even larger black hole. This process repeated over and over and over again throughout IC1101's history. Each merger added mass to the central black hole. 40 billion to 100 billion solar masses didn't appear overnight. It was built incrementally, through cosmic collisions spanning billions of years. But here's what makes this black hole's history even more fascinating. It wasn't always the quiet, dormant object we observe today. billions of years ago, when IC 1101 was younger and still actively consuming other galaxies, this black hole was one of the most energetic objects in the universe. When gas and stars fell toward the black hole, they didn't just disappear quietly. They formed something called an accretion disk, a swirling vortex of superheated material spiraling inward. The friction and gravitational forces in this disk heated the matter to millions of degrees, causing it to emit tremendous amounts of radiation. Jets of energy and particles shot outward from the poles of the black hole at nearly the speed of light, extending for thousands or even millions of light years into space. These jets were so powerful they could shape the evolution of the entire galaxy. They heated gas, preventing it from cooling and forming new stars. They pushed material outward, sculpting the structure of IC 1101 itself. The black hole, despite being tiny compared to the galaxy around it, was controlling the destiny of 100 trillion stars. But that was then. Today, IC 1101's black hole has gone quiet. It's dormant, no longer actively feeding on material. The accretion disk has faded. The jets have shut off. What remains is just the gravitational monster itself, warping space and time on enormous scales, but no longer producing the spectacular fireworks of its youth. Yet even in its dormant state, this black hole continues to exert influence. Its gravity still shapes stellar orbits near the galactic core. It still warps spacetime so severely that the laws of physics, as we understand them, break down at its center. And it raises a question that should make you deeply curious. If this black hole was once so active, so powerful that it shaped an entire galaxy's evolution, why did it go quiet? What happened to silence one of the universe's greatest engines of energy? The answer to that question reveals something profound about IC 1101's fate. The reason IC 1101's black hole went quiet is the same reason the galaxy itself looks the way it does. IC 1101 is dying. Not quickly, not dramatically, but slowly and inevitably, like a star fading at the end of its life. And understanding why reveals something profound about the life cycle of galaxies themselves. Remember when I mentioned that IC 1101 contains mostly old, red stars? That wasn't just a descriptive detail, it's a symptom of something much deeper. This galaxy has almost completely stopped forming new stars, and without new stars being born, the galaxy can only grow dimmer as its existing stars age and die. The question is, why did star formation stop? The answer lies in what galaxies need to make stars in the first place. Stars form from gas, specifically cold molecular hydrogen gas that can collapse under its own gravity. Our Milky Way has vast clouds of this gas scattered throughout its spiral arms. These clouds cool down, grow denser, and eventually reach a critical point where gravity overcomes the gas pressure. The cloud collapses, fragments form, and new stars ignite. IC 1101 has almost no gas left. The fuel for star formation has been depleted. But where did it go? How does a galaxy use up something as abundant as hydrogen gas? The answer connects to everything we've already discussed: the mergers, the black hole, and the violent history of this cosmic giant. Every time IC 1101 consumed another galaxy, the merger process heated up the gas. Those gravitational interactions, the collisions and tidal forces, pumped enormous amounts of energy into the gas clouds. Some of it got so hot, it was simply ejected from the galaxy entirely, blown outward into intergalactic space, where IC 1101's gravity could no longer hold it. The gas that remained was heated to such extreme temperatures that it couldn't cool down and collapse to form stars. It just sat there, too hot and too energetic to be useful. And then there's the black hole's role in all this. Remember those jets of energy I mentioned earlier? When IC 1101's central black hole was actively feeding, those jets acted like cosmic heaters. They pumped energy into the surrounding gas, keeping it hot and preventing it from cooling. Even after the black hole stopped actively feeding, the damage was done. The galaxy's star-forming gas had been either used up, expelled, or rendered useless. This is why IC 1101 stopped making stars. It ran out of cold gas. It exhausted its fuel supply through billions of years of violent mergers and black hole activity. Now look at what this means for the galaxy's future. The stars that currently exist in IC 1101 are ancient, and they're slowly burning through the last of their nuclear fuel. Red giants are expanding and eventually ejecting their outer layers. Massive stars that still remain are approaching supernova. White dwarfs are cooling down, fading from view, and nothing new is being born to replace them. IC 1101 is like a forest after the last seed has been planted. The trees still standing are old, and when they fall, nothing will grow in their place. The galaxy will simply grow darker and darker as more stars die, and fewer remain to light up the cosmic void. There are no bright blue spiral arms in IC 1101. Those require active star formation, young, massive stars that burn hot and bright, but die young. What IC 1101 has instead is a smooth, featureless distribution of old red and yellow stars, slowly marching toward their inevitable ends. The energy output of the galaxy is declining. With each passing million years, fewer stars remain active. The total light emitted decreases. The galaxy, which once blazed with the energy of an active black hole and trillions of young stars, is now settling into a long, quiet retirement. This is the fate of giant elliptical galaxies. They're the end stage of galactic evolution, the final resting state after a lifetime of violence and growth. They're cosmic graveyards, monuments to what once was, but can never be again. But here's something that should make you pause and wonder. We can see IC 1101. We can measure its size, count its stars, and study its structure. But most of what makes up IC 1101, most of its actual mass, is something we can't see at all. Something invisible, something mysterious, something that holds this entire structure together despite having no light, no stars, and no gas. And understanding what that invisible mass is will completely change how you think about galaxies, about the universe, and about reality itself. That invisible mass I just mentioned, it's called dark matter, and it's not just a minor detail in the story of IC 1101. It's the foundation. Without dark matter, IC 1101 wouldn't exist at all. Here's the unsettling truth. When astronomers measure the total mass of IC 1101 by studying how its stars move and how its gravity affects nearby galaxies, they discover something shocking. The visible matter, all those 100 trillion stars we've been talking about, accounts for only about 10% of the galaxy's total mass. The other 90%? We can't see it. We can't detect it with telescopes. We can't touch it, photograph it, or directly observe it in any way. But we know it's there because of its gravity. This is dark matter. Not dark because it's shadowy or hidden in darkness, but dark because it doesn't interact with light at all. It doesn't emit light. It doesn't absorb light. It doesn't reflect light. Photons, the particles that make up light, and allow us to see everything in the universe pass right through dark matter as if it doesn't exist. But gravity? Dark matter definitely has gravity. Lots of it. Think about what this means. When you look at an image of IC 1101, you're seeing only a tiny fraction of what's actually there. The stars, the visible component, are just the tip of the iceberg. Surrounding them, permeating through them, extending far beyond the visible edge of the galaxy, is an enormous halo of dark matter that contains 9 times more mass than all the stars combined. This dark matter halo extends millions of light years beyond the visible stars. If we could somehow see dark matter, IC 1101 would look even more massive than it already does. The luminous galaxy we observe would appear as a bright core embedded within a much larger, darker structure. But here's why dark matter is so critical to understanding IC 1101's existence. Gravity from normal matter alone, just the stars and gas, isn't strong enough to hold a galaxy this large together. The stars at the outer edges of IC 1101 are moving so fast that they should be flung out into intergalactic space. The galaxy should tear itself apart. It doesn't, because dark matter's gravity holds it together. The dark matter halo acts like an invisible scaffolding, a gravitational framework that keeps everything bound. When smaller galaxies fall toward IC 1101 during those mergers we discussed, they're not just attracted by the gravity of the visible stars, they're being pulled in by the dark matter halo, which extends far beyond the stars and captures victims from much greater distances. In fact, dark matter played a crucial role in IC 1101's formation from the very beginning. In the early universe, billions of years ago, dark matter began clumping together first, before normal matter. These dark matter clumps created gravitational wells, regions where the gravity was strong enough to pull in normal matter, gas and dust, which eventually formed the first stars and galaxies. IC 1101's dark matter halo was there from the start, growing through mergers just like the visible galaxy. Every time IC 1101 consumed another galaxy, it also absorbed that galaxy's dark matter halo, growing the invisible structure alongside the visible one. Without this dark matter foundation, none of the galactic cannibalism we discussed could have happened. The mergers, the growth, the accumulation of 100 trillion stars, all of it depended on dark matter providing the gravitational muscle to make it possible. And here's what should really capture your imagination. We still don't know what dark matter actually is. We know it exists because we can measure its gravitational effects. We can map how it's distributed throughout galaxies and galaxy clusters. But we don't know what particles make it up, why it doesn't interact with light, or how it came to dominate the mass budget of the universe. Scientists have been searching for dark matter particles for decades, building sensitive detectors deep underground to try to catch a dark matter particle interacting with normal matter. So far, nothing definitive has been found. Dark matter remains one of the greatest unsolved mysteries in all of physics, yet despite not knowing what it is, we know it's absolutely essential to the existence of structures like IC 1101. The largest galaxy ever discovered owes its existence to something we can't see, can't touch, and don't fully understand.